In most situations, objects will not rotate about an axis that passes through their center of mass. Some of these situations are a little simplified because of what's called the parallel axis theorem. This case applies to the situation when the axis about which the object will rotate is parallel to an axis passing through the center of mass. Let's look at this case, for example. We have this mass that's held by some support to the axis of rotation. The moment of inertia of this mass relative to this axis is going to be equal to the moment of inertia of this mass about its axis, its center of mass axis, that's represented by the dashed line here, plus mh squared, where h is the distance separating the line passing, the axis passing through the center of mass from the actual axis. This is what we call the parallel axis theorem. Okay, it applies to the case I just showed. For example, if I have a disk, instead of rotating about the center of mass, if it rotates about this axis, then I relative to this new axis is going to be I relative to the center of mass axis, I center of mass, plus the mass of the object times h squared, but h is the separation between the axes. In this case, that would be my h. Okay, this of course is not going to help us with all situations, but it helps with quite a number of situations. As an example, we are given here the expression for the moment of inertia of an object when it is rotating about its center of mass. Okay, so we have the expression for the moment of inertia of a long thin rod when it is rotating about an axis passing through its center of mass is 1/12 of ml squared. Now the question, what if we would like to find its rotational inertia about an axis that is 1/3 of L away from one of the ends, like shown here? So we use the parallel axis theorem. I is I center of mass plus mh squared. H, remember, is the distance between the center of mass axis and the new axis. That's my h. So h is going to be L over 2 minus L over 3, which we find here as L over 6. Then my expression is I center of mass, which is 1/12 of ml squared, plus mh squared, h being L over 6. So that's ml over 6 squared. Okay, so we do the calculations, put them in the same denominator. That comes out to be 4 over 36 ml squared, which is 1/9 of ml squared.